tendency yesterday, or measures of central tendency. We're going to specifically get to standard deviation is what we're building up to. But in order to do a standard deviation, you have to just talk about deviation. What does deviation mean? Deviation is the difference between any data value in your set, any x, and your mean. And remember, your mean can be represented like this. That's if I have a population mean, or it could be represented with an x with a bar over it, and that's the sample mean. So let's say I'm looking at this little example at the bottom, and we'll do deviation on our big chart in a second here. And this is macaw's height in centimeters at the Columbus Zoo. We would list our heights, and you can use the dot plot to do that. So what's my smallest height? Smallest height is 69. And then I have, what's next? 70. I've got two of those. I've got a 72, a 73, a 74, 5 and 6 are blank, 77, a couple 78s, and a 79. The next thing we need to do is find the mean. And they're using the population symbol here because this must be all of the macaws at the Columbus Zoo. So we need our calculator to do that. I'm going to count up how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nice, pretty number. In the numerator, you need to do the sum of all those values real quick. And what do we get? What is that? 740. 740, okay. Oh, and that one works out nice and pretty. If I divide it, I just get 74 then. Okay, so my heights are my data values. Those are my x's. Deviation is this calculation, x minus mu, or x minus your average, x minus your mean. So this could be a positive or a negative value. If you have a negative value, it means your data is below your mean. If you have a positive value, it means your data value is above your mean. If it's 0, it is your mean. So 69 minus 74 would give me a negative 5. 70 minus 74 would give me a negative 4, negative 4, negative 2, negative 1, 0, 3, 4, 4, and 5. Okay, do me a favor real quick and add up all of those deviations. Get the sum of that column. What do we get? That happens every time. So there's a way to check that your deviations are right. If you calculate your mean, calculate your deviations, the sum of the deviations should always be 0. Okay? So we're going to go to your chart now. We'll flip back to the rest of this in a minute. And we're going to do the deviation next. So our distances for our airplanes are going to be x. X minus our mean, and we can call it mu because it's a population. We could say the population is everyone in this class. And these are our deviations. Okay. What was the mean that you guys calculated for this? If I get it? 8.7. Was that exact? Okay. We can stick with 8.7 then for now. We're going to round this a little bit. Because we're rounding a little bit, our deviations might not add exactly to 0, but it's going to be pretty close. If we give it a lot of decimal places, it just gets kind of messy as we move forward. So 1 is fine. Okay, so now we're going to take each of our distances and we're going to subtract our mean from it. So again, it could be positive or it could be negative. All right, so go ahead and work your way down the column. 20 minus 8.7, 11.3. 13 minus 8.7, 4.3. 2 minus 8.7 is a negative 6.7. Negative 7.7. 15 minus 8.7, 6.3. 6.3. 4.3. Some of these are repetitive. Negative 7.7, negative 4.7, negative 3.7, negative 5.7, negative 6.7, negative 6.7, negative 8.7. 16 was 7.3, 29, 20.3, and negative 1.7. Okay, and let's go ahead at the bottom then. Let's just list the sum of that column. Remember, it might not be exactly 0 here because we rounded that 8.7, but it should be pretty close. So 11.3, 4.3, negative 6.7, negative 7.7, 6.3, 6.3, 4.3. All right, I got 0.1. Looks like. Okay, so again, pretty close to 0, approximately 0. All right, questions finding deviations from a data set. Perfect. Okay, let's go back to our definitions then. And let's talk about variance. Okay, so variance, to be able to calculate that, we need something called the sum of squares. The sum of squares is the squares of those deviations that we just calculated. So you'll notice here that inside that parentheses is that deviation calculation, and we're squaring it. So we can take all our deviations and square them, and then we calculate the sum of that. The sum of that is what we're going to do in our third column in a little bit here. And that value is what we're going to need to calculate both variance and standard deviation. If we're calculating variance, the formula that we're going to use for population, remember the symbols might change a little bit if it's a sample, is going to look like this. Okay, so in the numerator, these are all of our deviations we found. We square each of them and we add them up. So this is another formula that you're going to have on your purple sheet. You'll have it on test day. You just have to understand what it means. Think of it like phases that you're doing. We find our x's. Then we find our deviations in the second column, x minus the mean. Then we square those and then we add them up. Okay, so there's like 4 different parts in that numerator. That will be a single number then that we get from our table. Then we're going to divide it by n. It's a capital N because it's a population. And that's going to give me our variance. This is the symbol for variance. It's the lowercase sigma in our Greek alphabet. Okay. Good. Then standard deviation takes it one step further, and this is the big guy. So you can see that's the same formula as variance. The only difference is now my lowercase sigma is not squared. Instead, we've taken the square root of both sides, and there's a square root over my formula here. So what is standard deviation? Why do we care about it? It measures how varied the data is, and it tells us how close certain data values are to my mean, how spread out the data is. You may have heard in the past people talk about like something's 2 standard deviations from the mean or something like that. Okay, so standard deviation tells us distance, tells us grouping, it tells us spread. The further you have a value that's out from the mean, the bigger your standard deviation is, okay? And then the closer we are to 0, we have smaller standard deviations. And we'll look at spreads of data in a little bit. All right, so we're going to go back to our table now. And we're going to finish this by calculating the variance and the standard deviation. The next thing that you're going to do is do the sum of your squared. So sometimes you'll just see deviation squared here instead of the actual symbols for it. Okay, So we're just going to take, we've already done the x minus mu calculation. We're just going to take everything in the second column and we're going to square it. So again, you need your calculators for this. 11.3 squared, 127.69. 4.3 squared, 6.7 squared, negative 59.29. Okay. Then, after you have them all there, again, we're going to sum them up at the bottom. And that number is the important one. So summing up the deviations, just as kind of a check in the middle that we're doing it right. Summing up the squares is the value that we're going to then use in the variance and standard deviation formula. All right, let's add them all up. Oh, there shouldn't be negatives there. Sorry. I know everything squared's positive. Okay, I got, and somebody maybe confirm this for me because there's a lot of numbers here that we could easily mess up. 1,039.53 was my total. Did we get that? Did we get something else? No? Yes? No, we didn't get that? What else did we get? I might have typed something in wrong. What do we get? I must have missed a number. That's fine. Okay, what is it? 1, 5, 3, 5, 1. 0.5? Sure. Okay, good. Yes. Close enough. All right. So, variance. Let's do that guy first. So variance is our lowercase sigma squared. The formula is the sum of all our x minus mu squared, the sum of our deviation squared, divided by n. Okay. So that numerator is that number that we just calculated, bless you, and we pray is close to right with all those things we had to put in our calculator. Okay. So that whole part is done. We use the table for that. Denominator is just how many data values we have. So how many data values are up there? 17. Perfect. And then we divide. 1109.5 over 17 gives me 65.26. That's our variation. Okay. Next step is our standard deviation. To get our standard deviation, it's just sigma. It's just the square root of all that stuff we just did. Well, because we just did all that stuff, it's just the square root of 65.26. And the square root of my previous answer, I'll just use in my calculator, is 8.079 is our standard deviation. Okay, and again, this is all, if you want to make a note, population calculation. So we're assuming the data we collected was the entire class, therefore it was a population. Any questions? Okay, calculations are not difficult here. Formulas are not super difficult. There's just a lot of numbers and a lot of decimals and a lot of things you got to type in your calculator, so you just have to be careful. Good? Okay, so last thing I'm going to show you then. Everything we just did was population. If it's a sample, the formula changes just slightly. If it's a sample, you're going to use an S instead of that lowercase sigma for the variance and the standard deviation. Notice we see X bar now instead of our mu, okay, but that's just a symbol change. Calculation is not different. The only calculation that's different is the denominator. Instead of dividing by n, you divide by n minus 1. Because it's a sample, we include that extra minus 1 because it gives us a little more room for error because it's not the full population that we're calculating on, okay? So it's going to be an S and an X bar. S is still standard deviation variance. X bar is still your mean. And then just an n minus 1 in the denominator. Okay. On the back of your paper, there is another example. This is a sample set. So I want you to, and you guys can, you don't have to finish it in class today. We'll just make it like, we'll check at the beginning of the period on Tuesday when you come back. So if you need a little time this weekend to wrap it up, that's okay. I want you guys to try that last example, see if you can find the sample standard deviation, set up your table, set up your columns, work together if you want, and then we'll check our answers together on Tuesday and finish up this lesson. Okay. Homework that you guys have, let's see, 2-3, 2-2 is due tonight if you haven't finished it, 2-3 is due on Monday, and then 2-4 is due like the end of next week. Don't really need to worry about that. Just 2-2 and 2-3. Okay. All right. We'll do cell phone lotto, and then Jason, I owe a ticket, right? Are you the furthest? The rest of the period is yours. There you go. Wasn't drawn yet. Spade hasn't drawn my cell phone lotto.